I am Professor Antonio S. Marajas, and this is Computer Applications in Industry. Okay, so far, we have already explored the general programming procedure of your PLC. And to be very specific, the programming procedure of on-off inputs and on-off output. Okay, so we go now to a higher application of your PLC, or a higher programming method of your PLC, and that is using the basic register. Okay, so before we go into a more detail on the discussion, let us define first the word register in this particular subject. So register is actually a memory location that provides temporary storage of data, instructions, information, and numerical values associated with timers and counters. So in this particular discussion, register here is actually can be used as a timer or as a counter. Okay, so later we will deal with that. For now, we can say that within the PLC CPU, registers are found in two locations. One location of which is in your microprocessor. The microprocessor contains the so-called internal registers such as accumulator registers, data registers, index registers, condition code registers, scratch pad registers, and instruction registers. Okay? And aside from your microprocessor, registers can also be found in your random access memory or RAM. The RAM contains the external registers that holds variable information. So, kanang mga conditions sa itong mga switches and so on are, or the output, for example, the coil, are actually temporarily stored in your random access memory before it can be transmitted towards your internal registers. Okay, so as I've said earlier, registers can be used as a timer or as a counter. Okay, so we go now to register used as a timer. Now there are two basic PLC timer functions, one of which is your time delay on and the other one is your time delay off. Okay, so what we have here is a circuit of a time delay on example. Okay, so if you notice that this one here is programmed in the general form PLC programming method. So we have here input 001 as your switch, and then we have here CR0017 which is your output A, for example, and then we have here the internal contact of CR017. There are two of them, this one here and the other one is this one, and you have here the timer which is set at 8 seconds, and then we have here the final output which is your CR0018. Okay, so this is how the circuit works. When you turn on input 001, that means i-close ni mo ni siya, automatically CR0017 will be energized. Okay, that means that this will turn on. Automatically, the internal contact CR17 here and this one here will close. And that's the time that your timer will start the time, which is 8 seconds. Now, when it reaches the 8-second set time, your CR0018 will be energized. Okay, so CR0018 will only be energized after 8 seconds when your input 001 is energized. That is why we call it time delay on, no? So, nasa delay, which is 8 seconds. When you turn input 001, there is a delay. After 8 seconds, CR0018, which is your final output, is turned on also. Okay? Now, when you turn off your input 001, in other words, when you release your input 001, it will go back to its normally open contact. Your CR017 here will be de-energized. In other words, ma-turn off siya. So, automatically, CR017 internal contact here and this one here will go back to its normal condition, which is normally open. And automatically, CR0018 will also be turned off. Okay? That is how this time delay on circuit works. Now, the other side here is your timing diagram. So, how does the timing diagram works? Now, the timing diagram is based, of course, on your circuit here. So, we have here input 001. And then, these are the conditions of your input 001. You have on and your off. Now, we have here output CR017 and CR018. Now, when you turn on input 001, which is this one here, automatically, from your condition of your CR017, which is turned off, when you turn on input 001, it will turn on. CR17 here will be energized, so it becomes 1. Okay? And then once CR17 is energized, this is closed, then it will count 8 seconds before CR18 here, which is originally from off position. After 8 seconds, it will turn on. Okay? So, CR18 here will be turned on. So, 1 siya. And then, for a particular period of time, magdepende na sa imo, once you turn off or release input 001, for example, then automatically, CR17 will be de-energized. Mo-off siya. From 1, it becomes 0. And so as with CR018, since this is now open, automatically, your CR018 here will also turn off. So that is time delay on. Okay, so what we have here is an example of time delay off. Okay, so it says a motor and its lubrication pump motor. So here we have your motor represented by CR017 and the lubrication pump motor, which is represented here by CR019, are both running. Okay? Lubrication for main motor bearings is required during motor coast down. So after the main motor is shut off, this one here is shut off, the lubricating pump, this one, remains on for a time corresponding to a coast down time. The coast down time here is preset at 20 seconds. So in this example, lubricating pump remains, this one here, CR019, remains on for 20 seconds after the main system is shut down. Or in other words, if CR017 is shut down or turned off by releasing input 001 here, then the lubricating pump is de-energized. Okay? So, here's what happened here, no? So, if we will discuss the problem based on the circuit, so if your input 001, which is normally open, will not energize CR017. But if you notice that input 001 here, which is also the internal contact of input 001 here, these two here, which is normally closed, if this is normally closed, that means that CR018 is initially turned on. Okay, so energized ni siya daan, while the motor is de-energized and the lubricating pump motor is also de-energized. Okay? Now, what will happen is that if input 001 is turned on, this is turned on here, automatically your motor, which is represented by CR17, will be energized. Okay? If this is energized, then this CR19 will also energize. Why? Because when you turn on input 001, this will also turn on. Okay? Energizing your CR019 because the current can now flow towards your lubricating pump motor. Now, if this is turned on or energized, since CR019 here, which is your internal contact, is normally open, this will close, making this as your seal circuit for the lubricating pump motor. Okay? Now, what will happen is that since both CR17 and CR019 are turned on, when input 001 is released, kay push button naman siya, when you open it or release the push button, then automatically CR019, which is your motor, will shut down or de-energized. Whereas 019 will remain turned on because of the seal here, no, of your CR019, which is your internal contact. So the current will still be flowing here, so your CR019 will still be energized. Now, since input 001 here is released, in other words, open na po nimo siya, your input 001 here, which is normally closed, will go back to its normal condition, which is closed, no? Closed po ni siya. Then, automatically, if this is closed, then your timer, which is preset at 20 seconds, will now start counting up to 20 seconds, or the timer will now start. For 20 seconds, this CR018 here will be energized. Okay? And if CR018 is energized, automatically the internal contact here, which is CR018, will open after 20 seconds. Once this is open, automatically your lubricating pump motor, represented by CR019, will de-energized. Mapalong siya. Okay? So, in other words, there is a time delay which is 20 seconds in turning off your lubricating pump. Okay? So, that is how this circuit works. No? We call this the time delay off of your lubricating pump motor. Okay, so how do we interpret the operation of this circuit here in our timing diagram? So, again, initially, your motor is off. Okay? Lubricating pump, output 19 is also off. While logic 18, this one here, CR018, is initially turned on because input 001 here is closed. No? So, naka-turn on is sa daan. So, that is why your CR018, logic 18, is turned on initially. Whereas output 17 and output 19, which is this one here and this one, is off. Now, if your input 001 is turned on here, automatically your CR17, which is your motor, will also turn on, will be energized. In other words, from 0, it will become 1. Okay? At the same time, your output 19, since this one here is turned on, automatically your output 19 will also be energized at the same time. Okay, from 0, it also becomes 1. While logic 18, this one here, will turn off. From 1, it becomes 0. Why? Because when you press input 001, when you turn on input 001, this one here, which is normally closed, will open. So when it is open, CR18 will be de-energized, so it will go down from 1, it becomes 0. Okay? Now, while CR18 or logic 18 is 0, the output here in your 17 and 19 will turn on until such time that 20-second that your input 001 here is turned off. So if input 001 here is turned off, automatically your CR017, which is your motor, will turn off. This one, it becomes 0. From 1, it becomes 0. In this particular case, the condition of your input 001 here is turned off, meaning to say, gi-open na nimo ni siya. Okay, so CR017 is turned off. Now, even if CR017 is turned off, your CR019 will still be energizing. Okay, why? Because even if this is open now, but this one here, kasil mo na siya kaganiha, the current will still be flowing here towards your lubricating pump motor. So your lubricating pump motor will still be turned on. At the same time, this one here, kagi-release man, open man mo siya, then this one here will go back to its normally closed condition. Then that's the time that your timer will start the time or counting the time, which is 20 seconds as our preset condition. Then after 20 seconds, CR018 here will energize. When CR18 is energized, okay, this one here, when CR18 is energized, automatically the internal contact here, which is CR018, will be open. If this is energized, mo-open siya because it is normally closed, it becomes open once CR18 is energized. When this is open, automatically your CR19 will turn off. That is why after 20 seconds, your CR19 is turned off. Okay? So that is why there is what we call 20 seconds delay in turning off your lubricating pump. So that is how this timing diagram works based on our circuit.